Welcome to the SKF Racing Podcast. With the global warming becoming a more serious issue by the day, today we will discuss how the motorsport world is finding its way to reduce the damage done to our planet. I'm Volker and I'm here with Richard, Manager of Racing Innovation at SKF. Thank you so much for joining. In recent years, motorsport has taken great steps to make its sport more sustainable. Formula E, for example, has become the eco-friendly alternative to Formula One. And at the same time, Formula One has a goal to become carbon-free by 2030. MotoGP has also switched to more environmentally friendly fuels. SKF is working with various racing teams to help the vehicles achieve the goals. How can a vehicle be more sustainable in racing?
So first of all, hi Volker. Nice to be here. First of all, racing is all about new technologies and innovation. So I think you can really make a difference in terms of sustainability. As you mentioned already, it's already started. So with Formula E, Extreme E, and those kind of race series. And Formula One will use 100% sustainable fuels as well from 2026 onwards. WEC, the Endurance Championship, and the Rally WRC Championship they're already using sustainable fuels. So there's a lot of progress being made, and there's some real opportunity to make a huge difference in terms of sustainability generally in racing. And then you've got the new technologies coming as well, like hydrogen. So you've got Extreme H coming, which is like a spin-off of the Extreme E, just for hydrogen vehicles. 24-hour Le Mans with a hydrogen class coming in 2024. You've got hydrogen vehicles for the Dakar in 2024 as well. So a lot of exciting new technologies coming which can really help in terms of sustainability and helping save the planet, I would say, for other industries, other areas, automotive and so on. And SKF Racing is contributing to all of those, all these new developments with bespoke bearing solutions, in all the different application areas, gearbox, engine, wheels, suspension systems, and so on. And these solutions that SKF Racing are providing and developing cope with the higher speeds, the higher temperature, electric current insulation, for example, in electric drives, corrosion resistance, for example, in applications using water-based lubricants. So all these challenges that these new technologies, new applications are bringing with them, and SKF Racing is contributing with solutions for those. So we're developing bearings, for example, with new coatings, ceramic needles for needle roller bearings, for example. I mean, we already produce hybrid bearings with ceramic rolling elements, but needles is new for us. Composite cages that can cope with higher temperatures, higher speeds. So, for example, using materials like PEC instead of PEEK, which has a higher temperature limit. Solutions for water-based lubricants that I mentioned before, so stainless steel bearings or bearings with coatings. And we're even developing now 3D printed bearings, which gives us more design flexibility, so we can get even more weight reduction from bearings, which is, of course, really important for electric drives, electric vehicles, where you're looking for more autonomy and less weight can contribute to that. So all that is, of course, on top of what I would call the day-to-day work, which is, to continuously lower friction and lower weight, optimize our bearings as much as possible, which is, it's about choosing the right bearing for the job with the best quality, so that really, it's all about getting the maximum performance out of the vehicle with minimum energy, so maximum efficiency, and reducing our carbon footprint in the process.
Yeah, wow, it sounds like we are moving forward and making really a difference. And these 3D printed bearings you mentioned are indeed one of SKF's latest pioneering products. Can you explain how you make them and why this technology helps the environment?
Sure, yeah, I'll try. I mean, still very much in development phase, but the first tests that we've done with 3D printed bearings have been very successful. So we're starting to promote this new technology now, which is really exciting and opens up a lot of new opportunities. Yeah, we've developed special powder steels that can be 3D printed, and they're particularly special powder steels because they need to have the high hardness that's required for a bearing raceway. They need to have the quality of the microstructure and the cleanliness for such high precision components that go into a bearing. So that's taken up, it's been quite a lot of development just to get the powder steels. Then the production, how they're made in these special additive manufacturing printing machines. The actual process is quite difficult to explain over a podcast. I would say I would suggest you go online and have a look at some videos online of 3D printing, metal 3D printing with laser or electron beam. It's quite fascinating to watch the videos. But basically, I'll try and explain. You have a thin layer of the steel powder in the machine, which is locally melted by a very high power laser beam or an electron beam to form a horizontal single layer of the final part. So if you can imagine the final part, so in our case, a raceway bearing ring, is sliced up into many horizontal layers. So you melt the powder to create one layer, and after that layer has been formed, you cover it with more powder, and then the process starts again. You heat, you melt that powder, and layer by layer, you build up the final part. That's basically it. I hope it's clear enough. But as I said, look at some videos online. It'll be far more easier to understand. But then after you take the part out of the machine, then of course you have the standard processes of heat treatment. You need to post-process the part and machine some of the surfaces to make it a smooth surface, because it comes out of the machine quite rough, which is not good for a bearing component, of course. So there is some work to be done afterwards, but the process is far quicker than having to make special tooling, forging tools, sintering tools, and so on, and having to wait for the part to be made to that level before we can start machining it and assembling the bearings. And how does it help the environment? Well, there's several reasons. I mean, the part is printed directly from a 3D CAD model. So if you imagine that there are any design changes required from the customer, you just update the 3D CAD model and then you can reprint the part. You don't need tooling, as I mentioned, forging tools and so on. And if you modify the design, you don't need to then make new tooling or modify the tooling and so on. So there's already a lot of waste taken out from the fact that you don't need the tooling. Also, if you have the printer, for example, in a prototype shop locally, then there's less transport as well between the part being printed and the machining and post-processing that's required. So there's gains there in terms of transportation and carbon emissions due to that. The powder steel is also, the ones we're developing are fossil-free, so they don't use fossil fuels to make the powder. They can also be made from recycled steel, so again, helping the environment. We can also optimize the use of material, of course, with 3D printing. There's a lot less waste. If you imagine machining a part from a block, you waste a lot of material just because you're machining away the material that you don't need. With additive manufacturing, you're adding material, so you're just adding it where it's needed. So there's a lot less waste. And then, of course, you can actually optimize the performance of the bearing itself by designing it with reduced weight. Because you can, with 3D printing, you can have hollow shapes, hollow interior, new shapes, new oil channels, for example, and things that you wouldn't be able to do from traditional manufacturing methods.
You can trust me. To me, it sounds already really impressive without seeing anything. But let's stay on this environment topic. And my next question, do you think motorsport can be completely environmentally friendly? What else is SKF doing to become carbon neutral?
I think motorsport, will become completely environmentally friendly. I think it has to in order to survive. So, and I'm convinced it will achieve those goals. Although it's important to say that it's not just about the car itself. if we think about Formula One, for example, the power unit in the car actually only represents, it's less than 1% of the carbon footprint, the complete, when we take into account the complete carbon footprint of an F1, including racing, transportation, and so on. So that's the area that needs to be focused on as well, is all the logistics for the race events, the transport, the factories involved in producing the parts and so on. And that's where SKF has a role to play as a factory that supports F1. So it's right through the supply chain and the race events themselves that where the focus needs to be made. And that's the same for SKF. I mean, it's not just the bearing itself that we need to be looking at. We need to be focusing on the complete supply chain there as well. So transportation, our operations, our factories are all important as well. And what are we doing to become carbon neutral? Well, there are so many things. It's impossible to cover all that now in this podcast. What I would suggest is that people go on SKF's website, www.skf.com, and type sustainability, and there you'll see all the things that we're working on. There are pages on tidal energy projects, for example, recond oil, where we filter oil so that it can be reused over and over again. All these initiatives and all the things that even in the factories, using solar panels to reduce energy in the factories, biomass facilities and so on to heat the factories, all these great initiatives that are going on to improve the environment.
Yes, you're right. And until we get to be completely green, it's true, we have a long path to go. And what are the new challenges you think we will be facing soon?
I think the biggest challenge for SKF is the steel that we use. We use so much steel for the bearings, and steel it consumes a particularly huge amount of energy. And if we look at the complete process, gives off a lot of carbon emissions. So that there needs to be a big push for the development of green fossil-free steels, and that's something that SKF is hugely involved in at the moment and really pushing. That means that we need green hydrogen as well. That's another challenge. There's a lot of work going on in that area, but that needs to come. Carbon capture as well, taking carbon out of the air and using that to produce fuels and green steel and so on. That's all a big challenge. And then I would say the other side is the metrics, how to measure carbon neutrality. That's also important, how to measure it in a standardized way with proper certification and so on to avoid what we call greenwashing. Of course, we need concrete solutions that work and that actually make a difference. And those differences need to be measurable and measured in a correct way. So that's also something that SKF's working on. There's, again, on the website, you can see there's a dashboard tool, for example, where you can now check the CO2 footprint for various bearing selections and so on. So I think that those are great initiatives that are really going in the right direction.
Really interesting. And now, out of curiosity, as expert in sustainability and racing, do you have an electric car? If not, are you planning to buy one or not very convinced yet?
I don't have an electric car, no. I do have an electric bike, but I don't have the electric car.
First step. First step, yeah?
First step, it's a first step, yeah. I would love to get an electric car, yeah. I'm not against it at all. But I mean, especially now that the autonomy is increasing as well, so it's starting to become more interesting now. I think there was a time when the autonomy just wasn't there and it wasn't so interesting. But I still think, though, there's a lot of work to be done in terms of fast charging, more convenient charging, I still think this idea of getting a cable out of the boot of the car and plugging it in, and it's not very convenient. I'm not sure that's the long-term solution. I do like this idea of induction charging or something like this, where you can just drive the car onto a platform and it charges up, but it also needs to be a lot quicker, I think. But that'll come. I mean, at least electric cars are here, and it's a good short-term solution, I think. But I think we'll soon start seeing other solutions, other technologies that will come from racing. As we mentioned at the beginning, all these new technologies that start off in racing and then are used by other sectors. So hydrogen, e-fuels that we talked about, I think that'll come into the automotive sector. And I think in the end, there won't just be one solution. I think the final solution will be a combination of electric, hydrogen, and e-fuels, and we'll see then what the best solution is, what the best car is to buy, and it depends on the usage as well. I mean, electric's great for just going in the city, in the towns, but if you have to go a long distance, if you do a lot of driving, it's maybe not the best solution today. We'll see.
Yeah, we will see, and we will see what the future brings us. So far, I can just say thank you for your time and for the interview, and thank to all of you for listening to us. Stay tuned and don't miss the next chapter.